recording on this computer. And I think we are golden. All right, and I'm going to start sharing my screen. Okay. Yes, don't look at my hanging pants curtains. All right, folks, welcome to the talk today. I'm going to be talking about comprehension and communication in code. And just a quick outline of the lecture. I'm going to spend about the first 10 minutes, 15 minutes. Oh, let me keep my chat window open so I can see any messages. I'm going to spend the first 10 to 15 minutes just kind of going over some terms in what we are going to be covering. And then I'd like to spend about 25 to 30 minutes actually doing some exercises to go through and kind of go over some questions about what it means to kind of comprehend and communicate about code. They'll be partially interactive. I want to kind of demonstrate some things first and then have some folks give it a try. And then I'll need to wrap things up about 5 minutes before 11, so I can get onto my next call. Awesome. And as always for lectures, if there's something you need to repeat or want me to go back over, feel free to interrupt. I probably won't see things on chat in real time. So if you could just unmute yourself and use your voices to interrupt me, I do not mind at all. Otherwise, I'll try and leave a little bit of space afterwards for questions if possible. Awesome. And of course, as always, this video is being recorded, so you can see the video afterwards, and I will share the slides as well. Cool. So what does it mean to comprehend code? Let's talk about this for a sec. I want to use these two terms, comprehension and communication, as kind of like they're sort of like the two sides of the same coin in some sense. Like communicating about code is a way of expressing comprehension, and comprehension is a way of communicating with yourself about whether or not you understand code. And this is a very difficult question to answer and to formulate, which is like, well, what does it mean to understand code? And I think something that might be, maybe this is obvious to many of you by now, maybe it's not, is that nobody fully understands everything about code. That like we're always working with this kind of partial understanding and partial assumptions and slowly adding on extra pieces. Yeah, there's no possible way that I could understand every piece of code in the world or any human code, right? Even people who work on large applications only understand kind of small portions of it. But the kind of salient point that I want to get to today is what does it mean to understand code that you write? So that when you write code, you can feel confident in your understanding of it and feel that you could discuss it, explain it, communicate about it with others, and collaborate. I guess that's kind of the end goal of all of this, is that having a solid sense of comprehension and the ability to communicate about code gives you a huge advantage in collaborating with any other software developers, because you're going to have to talk about the code that you're writing together and how it's going to work together. So I want to take this discussion and break it into a couple different parts. So one answer is that being able to describe, explain, and reason about your code is one way to tell if you can comprehend it or not. And I realize my slides are a little bit, oh goodness, come on. Yes, so I want to break it down into these three different areas: describing code, explaining code, and reasoning about code. And by the way, these are just my terms. They're not like kind of some standard technical terminology that I'm using here. But they're in sort of increasing order of complexity and level of comprehension, I guess. So let me go through each of them in turn. The first one, describing code. This is about the what and the where of your code. So it's kind of the most basic and foundational aspect of your comprehension, and it's really sort of the most crucial piece to having any kind of communication. If you can't agree on sort of what the code is and where it lives, it's going to be very hard to kind of do anything more complex than that. So this is things like, where is this function called? These are questions you might ask yourself or somebody else about the code. What is the data type of this variable? What are the inputs and outputs to this code? How many times does this loop run? These are all kinds of things that are sort of, they're right there in the code, and you should be able to sort of see them and understand them fairly quickly. And without this sort of baseline understanding of how to describe code and how to talk about it and how to think about it for yourself, it's harder to do more advanced explaining and reasoning. So let's go to the next piece, explaining code. In contrast to the what and the where, this is about the how and to some extent the why. So when you're explaining code, you're doing things like talking about the design and like architecture to some extent of how you went about creating this artifact. So this is where your design and creativity and problem solving come in. And this is about things like, if you can explain your code, you can explain what this line of code does. Like what effect does it have? Why did you pick the certain name for this function? Like, why did you name it this thing and not another thing? What was the reasoning behind that? Why did you do that? How many times does this loop run? How many sort of like, let's see, what's another way to put this? Or like explaining, why you had to create an iteration in the first place, explaining why your code needed to take a certain approach as opposed to another. And so this gets at a bit sort of a higher level of thinking, rather than just the building blocks that you're using in your code, but rather how you as a designer and a thinker are putting them together, and how that makes sense. And for yourself, this is kind of like one of the things that you might do when coding. I don't know if you've heard of this term, like rubber ducky coding, which is where you should explain your code to a rubber duck sitting on your desk as a way to check to see, like, does it make sense? Oftentimes just explaining your code to something else, even if it's an inanimate object, can help you sort of see like the flaws possibly in your reasoning. And the final piece, reasoning about code. This is sort of the most kind of high level in my sort of description right now, which is that it deals with the logic and the use of the code, sort of beyond its most sort of obvious design and construction. So this is about being able to think about other possibilities, all the different ways your code could be used or changed or modified, to kind of develop it's like a more lateral thinking and more kind of like higher level thinking about the code and its use. So this is things like, if we were to change the input to a different data type, what would happen? Or what would happen if the function is not passing arguments? What happens if you call it without any arguments? Or what happens if this certain dependency is missing from your code? Ways to kind of talk about how the code might respond to different inputs or outputs, or how changes might cascade and have effects around the code. And the reason I say this is kind of a more sort of high level way of thinking about code and comprehending and communicating code is because you really have to understand kind of how the code works, and from a lot of different sort of perspectives and dimensions. It's more than just sort of the like what's written right there. It's about thinking about different possibilities and about different ways that it could be expressed and used. So I mentioned these three things just as a way to kind of give us some broad categories to work with, and we're thinking about what it means to comprehend code and what it means to communicate about code in these different levels. And I really want to emphasize the sort of the ascending importance here. It's pretty hard to explain how your code works if you don't know what the things are and like where in your code certain things happen. Same thing, it's very hard to reason about code if you couldn't explain why you wrote the code in the first place, if you can't really explain what a certain function does. So these things sort of build upon each other, and it's important to make sure you have kind of one foundation before you add the other layer. And I'll say too that this is something that I think is a good practice in any kind of debugging or any kind of exercise where you're finding yourself in a position of being stuck, when you're like hit a wall and you don't really know what to do next, is to kind of rewind and say, well, can I describe the code that I have right now? Like, what are the things in it? Where do things happen? What's the flow of control? And if you can get through there, can you explain sort of why each piece exists and why it works the way it does? And oftentimes, by the time you get to that point of having to explain how your code works, it usually the answer often like pops up fairly quickly. When you get into reasoning about code, usually this is when you're dealing with sort of more complicated bugs, things like race conditions, if you've heard of these, or things where you might be dealing with randomness, or things that operate in different timescales, where it gets kind of more confusing and difficult to really see an obvious answer. This is more than just like a syntax error that you're dealing with. This is usually about sort of the architecture, which is probably not as relevant to folks in phase 1 or phase 2 that are listening. So let's see, let me keep going here. I want to make a quick analogy to kind of tie this to something outside of the world of coding. Is that coding is kind of like building a house, that you as a coder, we are all kind of like contractors who have to create some structure. In the sense that you have to design it, to think about it, sort of what it should look like. There are certain rules you have to follow, certain guidelines. As a builder, you have to follow, physics, the rules of physics, and usually some kind of building code. But there's also room for creativity and expression. And kind of the way that it's similar in the sense of sort of comprehension and communication about it is that, a great contractor can build a nice looking house and it could look beautiful, but you really want to know if it's actually a quality structure and if they understand what they're doing. So, for example, if you were, wanted to hire a contractor and you asked them, well, like, where are the load-bearing walls in this house, or what light switch does this, what light does this switch turn on? You probably want them to be able to answer these kind of basic questions about the structures they're building, right? As a way to sort of check, like, are they actually building something they can comprehend and can reason with? Another distinction I want to make is the difference between having the answer and finding the answer. Because I think, at least for me, when I was beginning to code, a very common stressor that I had was thinking that coding meant like sort of having every single answer on the tip of my fingers that anybody could ask. Like if I don't know something, that's like a huge failing. And I think this is an overblown expectation, and that most of the time, the important thing is being able to find some answer for yourself, or in an interview situation, or in any kind of collaboration situation. You might not have the exact answer. It might not be obvious why you wrote the certain function. It might have been a few days ago or a few weeks ago, and you have to kind of go back and think about it. Or it might not be obvious what this certain library that you imported is doing. So the important thing is not so much sort of having that knowledge immediately on hand, but the ability to find out an answer through kind of experimentation and prodding, so you can rebuild that knowledge and rebuild your sense of the code. And you do things with, like, this is where kind of using lots of console logs is important, or looking at documentation, or trying the code with different inputs to sort of get a sense of reminding yourself, okay, this is how it works, and now I can understand and explain it a bit better. So I want to sort of emphasize that kind of finding the answer and being willing and able to kind of seek out an answer when you don't know it. And I missed a part. There was a slide I wanted to talk about. Let's see, before I get into the code. But Google is being very slow with my slides here. Before I jumped into the code, I just wanted to give a quick personal story. When I was first learning to code, I was just like reading books before my personal assistant job. Like in the mornings before I'd go to work, I would read a few chapters, and then at night I would like try things out. And so after about a year, which hopefully translates to about probably some amount of time that you all put in about 2 weeks of work at the Guild, I was like, okay, I'm like about as far as I can get. I want to like apply for an internship or somewhere where I can actually start working on things. And so I applied for this internship. It was like not paid. It was very, very low level, but it was still something I had to interview for. They had to sort of check that I'd done my research, and I felt pretty confident. I'd built a few Rails apps, or at least I thought that I had built a few Rails apps by that point, and I'd written some Ruby code. But I went into this interview, and they just asked me some very basic questions about my code, and to explain how it worked and what things were doing. And I just crashed and burned. Like, I couldn't give them a clear answer to anything. And I went in there feeling fairly confident that I was like had a decent shot at the interview, and leaving, I knew that there was no way. And the main reason was because I had spent that entire time studying in complete isolation. I was just reading books and trying code for myself, and I didn't actually spend the time sort of thinking about what the code I was writing was actually doing. It was usually following a tutorial and just kind of like going along with the instructions as I found them. I was treating it like a Lego set, basically, just like kind of assemble these things. So that was just sort of one important realization in my in my past of trying to be a coder that I failed, and it sort of hammered home to me the importance of being able to not just be able to write code, but also be able to talk about it with other coders and to explain how the code I'm writing is working. So let's jump into some code. Sorry, I heard somebody.
Yeah, this is Justin. Can you just say the three things again, the three different levels?
Yes, absolutely. So the three levels I'm talking about are describing code. That's the what and the where. Explaining code, kind of the why and the how. And reasoning about code. This is about making kind of logical inferences and hypotheses about the code.
Great, thanks.
Cool, no problem. So I want to jump into some code, and I want to start by kind of giving an example of how I might describe a code that I've written. So I'm going to give you a small script code that I've written, and come up with some questions in each of these three levels: describe, explain, and reason about. And then I think what I'd like to do is switch to some code that somebody else has written, and we can together come up with some questions about how we might kind of build comprehension of this piece of code that none of us have seen before. So let me start with this code that I wrote. I already have the link open. It is my solution to the IMDb query exercise. And I'm going to do this in Atom here. So I already have this loaded up. So it's a single file. It has a package JSON because there are a couple of dependencies, but roughly it's a single file. So kind of the first thing I'm going to do is write a few questions at the top. Normally I wouldn't do this in comments, but this is kind of like externalizing my mental process. So some questions that I might use to describe this are, yeah.
Would you just increase the font size?
Yes, absolutely.
Thank you.
How's that?
Perfect.
Okay, great. So first thing I might ask is like, what does this code do? This is like a high level explanation. And I might ask things like, what are its dependencies? This is more of a description. I just want to know what are the libraries it depends upon. And then I might go through and check out, it's like, what are the functions, their inputs and outputs? And then maybe something like, this is another description. And then what happens when we run this code? This is more like an explanation of how the code works. After we get through these, I might find some other questions that come up as I'm explaining things, and we might end up doing some reasoning about it. But I'll start with some of the basics. So first thing, what does this code do? What's a good high-level explanation of this code? Let's see. I'd say a pretty decent high-level explanation of this code is that it takes in some search term and searches the IMDb movie database for movies that match that search term, and then prints out the titles of the movies for me. I'd say that's a kind of a rough high-level explanation. It doesn't get into the details of how the code actually works. It's sort of just like, what are the inputs and what are the general outputs of this code? Maybe a poor high-level explanation would be it's code that works with movies, or it's code that runs functions to print out some strings to the console. None of these things are very specific about kind of what its purpose is. So I'd say let's stick with an explanation of it takes a search term and searches IMDb for movies that match the term, then prints them out, prints out their titles. Okay, what are its dependencies? So this is one, it's a description, so it should be fairly easy. I should know exactly where to look for these. And luckily I've written this code with the dependencies up top, so I know, well, it depends upon this require promise module and it requires upon this Cheerio module. These both happen to be NPM packages, so I created a package JSON and have Cheerio and request promise. Looks like I also have this request. I'm not sure if that's a pure dependency of request promise or not. This might be a duplicate code. I can come back to that. So I know these are the dependencies. It requires these. It also has some kind of implicit dependencies. I know I'm using Node, for example. This is not going to be running in a browser, but it has to be run in Node. So that's one of the dependencies this code has to run in a Node environment. And I have to be running in a Node version that uses some of the features I have here. For example, I'm using arrow functions and string interpolation here. And these are features that might not have been available in a much older version of Node. So there's some kind of like implicit dependencies in the code that I can talk about too. So I'd say kind of a very basic answer to this question is that packages, it depends upon the package's request promise and Cheerio. Okay, then we can ask, well, what are the functions in this code and what are their inputs and outputs? So let's go piece by piece. So build URL, one way I could describe this function is that it takes in a search query. And I believe this is a string, but I'm not sure because I don't know where this function is being called yet. But I believe this is a string, and it returns, this looks like a URL pointing to some page in IMDb where the search query is interpolated as into this URL. And looks like it's interpolated right into this Q parameter in the query string. So there's all this other stuff. I'm not sure what any of these things do, to be totally clear. But the important thing that it looks like is that it's actually adding it to this Q key here in the query string. And this function just returns that whole URL with the query string now embedded into it. So it's fairly simple. Parse results. Okay, parse results is a little bit less explicit. It takes in something. I'm actually not sure what this is. I'll have to go back and see how this is used to describe this. But I can I'll make some other inferences around it. It does return, this looks like a query, and to me this looks like jQuery. So I know this is probably something to do with the Cheerio library that looks like jQuery. It does some query, it looks like a query on HTML to get some table descriptor or table data elements that have this result text class. It maps them all by getting their text and replacing the text. It looks like there's some empty spaces and a dash with a new line, so it adds a new line at the beginning of each of these things, and then calls get. And I'm not sure what get does. So my rough guess right now, I don't have a good description of this function. My rough guess is that it takes in this function that allows me to query HTML, and I don't know what it returns. And it returns whatever .get returns, but I'm not sure what that is. So I'm going to go and look at where this function is used to give myself some more context. So let me see, where does parse results get used? Okay, just right down here on line 28. So let's see what this function does, and I can kind of get some context around how to describe parse results. So this function is called search IMDb. Looks like it takes in that query itself. And here's what we call build URL. So it takes in a query, creates a new URL, and I'll call that URI here. And then it creates an object with some options called URI and transform, which is another function called load with Cheerio. So this looks like where I call this Cheerio.load function. And then this function searchIMDb returns this request promise. RP is request promise here with the options passed. So I'm guessing this is going to go and make an HTTP request, and it returns a promise because I then called then on it. And after calling then, I parse the results. So parse the results should be something that's receiving whatever the response from this request was, and then parsing it. But because it's not responding with some body, it's responding with this function, I'm guessing that the transform key here is actually performing some transformation and responding with this Cheerio function that I can use to query the HTML. So to validate all of these guesses, right now I've just made kind of like 4 or 5 different assumptions in describing my code. And I should probably validate some of them. And so the way that I validate this is to say, okay, I want to know what Cheerio.load does. This is when I'm interacting with the Cheerio library. So I'm going to go and take a look at this really quickly. Cheerio npm load method to allow me to describe this function better. So I'm just going to write to the Cheerio site. And okay, there's actually an example right here. So it looks like it's assigning Cheerio load. It takes in some HTML and returns a function that I can use to query things like use sort of jQuery style querying the HTML and get aspects and interact with it. So here it's like setting the text of the title to hello there, or adding a class to h2 welcome. And you can see the results of the HTML there. Okay, so understanding of Cheerio load now is that it takes in some HTML string and converts it to a function that we can use to query it in a manner very similar to jQuery. So that makes this make a bit more sense, is now I know that, okay, request promise, it's going to go get the HTML from IMDb, this URL here, use Cheerio to transform it into this function, then I can now query it and interact with it. And this parse results piece is taking in this sort of Cheerio query function and returning the results of this query. So we're getting some elements out of the IMDb, this HTML page, mapping them to add some new lines between each of these pieces of text, and then calling .get. And this is the last piece that I don't know what it does. I'm not sure what this .get method does. So I'm going to look at that. And it's something that Cheerio is using because I'm kind of stringing things onto this Cheerio function. So I'm going to go see what .get does. .map, nope, nothing in .get here. Do they have a full documentation somewhere? Where else do we get? Okay, interesting. There's not actually there isn't an example of, or an actual entry for .get here. So this takes me to my next good point in comprehension is like when you can't get a direct answer, how can we learn what this thing is? So I think the easiest way to do this would be to say, okay, what does parse results return if I just return this map part, and what happens if I return it after calling get? And so I think what I'll do is test it out. So let's see. Let me go into IMDb, npm install here. I'll get that install running while we're looking at this a bit more. So what I want to do is say, okay, if I can parse results, then let's return, here's our full function. What I want to do is log out this result. And sorry, my code is being a little bit jumpy, I think, because of the high bandwidth here, or high processor speed in recording this video. So I want to see what these two things do. I want to see what this one does. I'm going to assign it to a variable here, const. We'll call this result, map result. And then I'll say const get result is equal to map result dot get. So I basically rewrote the code from below above here so I can see what map result is. And then I can see what get result is. I want to see the differences between these two things. And I should probably give myself some indicators here. For map result and get result. And that way I can actually see sort of what is the difference here, and I can make some inferences around what get actually does. So let's see if the installs worked. Okay, great. And if I remember correctly, I run this code by doing node imdb, and then I pass a search term like, oh, what's a movie? Forrest Gump or something. And it's taking its time. Okay, so, oh, it's printing out a lot of stuff. That's way too much. Maybe I can give it something a bit smaller. Superman, maybe? Oh, it's really returning a lot. Okay. So what I'm going to do is actually, I'm going to skip printing out the final results because I just want to see my debugging here. I just want to see the things that return when I'm logging out my map result and get result. Okay, so these are big things. Let's go back to the top here. These are very large arrays. So what it looks like, okay, so here's my map result. So map result is actually this object. So map result is this object here with each of these keys being, looks like index numbers. But then get at the bottom, after I call, so there's the rest of the object here. Yikes. This is very, very long. Not a good example. Get result is just an array. Okay, so based on the differences here, map result returning an object, get result returning an array, my guess is that get converts the object returned by this query to an array, which is a lot nicer for us to work with because we just want the strings of text here. So I now know that parse results returns an array of these strings. So it's returning these strings with each of the movie titles in them. I don't know why I thought Superman would return fewer strings. There's all kinds of Superman movies. Okay, so we've gone through build URL, parse results, load with Cheerio, and search IMDb. And now I know that search IMDb takes in the query and returns a promise that, that should resolve to this HTML being queried and then parsed so that we just return the titles of these movies. So that's kind of each of my functions in turn here, describing each of these functions. And notice that like that took us two different things. I had to both sort of read the functions as they are written and make some deductions around kind of how they work. I also had to look up some documentation, be able to describe them in their complete, like describe how they work. And I had to make some tests, like to actually kind of poke at my code and figure out how it works when the documentation wasn't able to supply a direct answer for me. So those are kind of some of the things that now give me a sense of, well, I understand this code a lot better. I know how each of these lines work and what each piece does. And the final thing is what happens when we run this code. So the kind of explanation is, well, let's see. When I run this code, what's going to happen? First, it's going to require these two packages and assign them to these constants, RP and Cheerio. Then we're just going to define a bunch of functions. So we define this function, define that function, define this function, define that function. And at the bottom here, we have this if branch, if module.parent. And this code is actually going to execute some functions. So here, if I were to say, describe what happens when this code is run, I would say, well, it first requires two modules, defines a bunch of functions, and then if this condition is met, and what this condition means that basically if this code is not being required by another module, but if it's actually being run directly from the command line, which we're using here when we call node.imdb or node.imdb.js. So if this code is being run directly, then execute inside of it, or everything inside of it. And here we're getting the query term from the argv array of this process and running the search imdb method. So running this function search imdb with the query term, and finally taking the results from that query and, well, if I didn't comment that out, logging out those results as a string joined by a new line. So this is kind of the only code that I'm concerned with. This is sort of the main bulk of what's happening in when I actually run this code from the command line, using each of the functions defined above. Okay, that was about 15 minutes or so of a fairly in-depth explanation and description of how this code works. What I'd like to do next is open up some code that none of us have seen before. And together, let's come up with some questions to see if we can build some understanding and comprehension of this code. So I'm going to open up this other module here. This command line to-do list with callback solution. Maybe some of you have done this benchmark before. I think this is Jared's solution. But I haven't looked at it before, so we're going to figure it out together. Okay, so the first thing, I'm curious, when you open up a new folder with a bunch of code in it, where do you go looking first? Where do you start if you want to kind of understand how this code works? Oh, open question. Does anybody have a good idea? And there's no right answer here, too. I'm just curious about
I tend to look at the package JSON.
Okay. Yeah, I think that's a great place to start. And why do you do that?
To learn what the project consists of, like what dependencies it has, if any, and yeah, get oriented.
Yeah, great. Okay, I think that's a great place to start. So by looking at the package JSON, you kind of answer some of these described questions already, right? It's like, what are the dependencies? Are there any scripts involved in this project? What is it called? What did the coder decide to name it? And this package JSON is pretty empty. So there's not a ton we can learn about it, other than that this person didn't write a ton of code to fill out this package JSON. So maybe there aren't any dependencies in this code, which would make it a bit simpler for us to reason about. So then, since this isn't giving us too much, let's think about the next place we would go. What other files might you look at next to kind of keep exploring?
README files.
README files. Okay, there's no README either. What are we going to do next?
The first data file .js.
Yeah, that's great. Okay, so let's take, we're in the root directory here for this file. So we've got a data file.js and a task.js in here. So these are two, looks like JavaScript files that are right in the base of this project. So they're probably kind of more important ones. We can sort of assume that they're more important than anything inside of a folder, for example. So let's see what data file does. Okay, so what kinds of questions might we ask then about this script? There are 39 lines of code in here to give you a sense of how the script works and what it is and then how it works. What kinds of questions that we asked about the last stuff what we want to use here? Yeah, go ahead.
What is home? Process.env.home.
Yeah.
What is it set to?
Great question to write. Yeah. What is home? Where is home? What is this process.env.home? Oops. Okay, that's a great question. So we know that's being used inside of this path.resolve, and then we're calling .task.json. Okay, that's interesting. We'll have to figure that out. What are the questions that we ask about this? Let's kind of build up a little backlog of questions, and we can start going through them piece by piece.
Maybe a high level question of like, overall, what does this code do?
Yeah, great. Okay, so if we're going to say, what does this code do? Let's look at each of the statements that we're making here and see where anything actually gets run. So you can see in the top, okay, it requires 2 modules. Okay, nothing really happens there. Define this function read data file. Let's ignore that for now. I'm going to collapse some code so we can see just sort of the high level stuff. Defines another function write data file. We collapse that. And this function bail just logs an error and then gets to the process. Okay, and collapse that. So we define we define this one constant and 3 functions, and then define module exports. Okay, so this code doesn't actually sort of do anything in particular in the sense that it doesn't run any functions. It's just defining functions then running them for export. So what could we maybe make a guess about how this code might be used then, if this file doesn't actually run any code? It just defines some functions and exports them.
It could be used as a module.
Yeah, great, right? So this kind of puts this file in the map now, right? We have this map of, okay, empty package JSON, no README, but data file.js. This is kind of one file on our map here, but it's not being used directly. We're not probably going to run node data file.js, but it's probably a module, right? So let's go see where might it be used. So let's see where it is required. Data file.js. I'm just going to do a project-wide search. And it looks like it's used in, besides itself, in the 3 command files. So you can see that it's required in both commands add, done, and list, in actually multiple places. Or no, sorry, not multiple places. One line is just reading twice. So I think a good place next is, okay, we have this map. Here's this module that's going to be used by these 3 different files. Let's just start with one of these files and see how this file works as a way to keep going. So, okay, so now that we have this file that's requiring a data file, so now we have this kind of extra node on our tree here. What questions could we ask of this file, of how it works?
What does it mean by add specifically?
Yeah, great question. So like, this is kind of a question that is more of an explanation, right? In the sense that we're asking for the design intent of the coder, who in this case is not present. So we can't ask them directly. We have to make some guesses here. Like, what does it mean to add? Why would they use this word add for their file as opposed to some other word, right? And we can see that the file only also exports a function. So let's go see where this file is used and how they may be using add in a different sense. So I'm going to search again for where commands add is required. And it looks like it's required in the task.js file. So here we are in task.js. It looks like it's requiring the add command, the done command, and the list command. And I'm just going to do a find for all the places that the word add comes up. So each time that we're using this word here. And so it looks like it's using the require down here on lines 9 and 10. And that's it. So, all right. We know it's only being used in these 2 places. We're calling the add function here with the second argument. So from that, what kind of things like, and it's used in contrast to done or list. So what else might we want to find out about about this file here? We know that kind of add is being used as one of these possible branches in the switch statement. So the next question that I have is, what is add passed? What is the argument that we're giving to the add function? So that's kind of like a path that I want to trace backwards to the source of this value. And in this case, it's luckily pretty close. We can see that the add function, as well as done and list, are all being passed the second argument, which in this case is mapped to process.argv.3. So I know from how the process.argv array works is that if I were to call node task.js, this would be argv2 and argv3 are these arguments. Like the second, the element at index 2 in this argv array is sort of the third thing you type, the third word in a command. And the element at index 3 is the fourth word in the command. So I'm guessing, let's see, we know that add is passed the second argument. Well, what happens to the first argument? Okay, so because the first argument is the basis for our switch statement, it looks like this first argument is going to either be add, done, or list. So from that, I can guess, all right, how is this code used? Well, I'm guessing the first argument is going to be either add, done, or list, because those are the options given in the switch statement. And if I were to do add, add is going to take whatever second argument I give it and call it. So I could say add foobar. Okay, interesting. That worked. They didn't error out. So where might I go next to figure out like what happened when I called the add function with second argument?
Well, you have a list command, right? So it could be assumed that that word list would list out whatever you add.
Sorry, what was that, Phil? I couldn't quite hear you, Phil.
I was just saying you could look at the commands because there's one that says done and then there's one that says list. But I'm assuming the word list means it would list out items that you've added to this task item. So.
Yeah, great. So Phil, what you just did there was you made, you identified a pattern. I just want to kind of point out that like the comprehension building exercise you just went through, even if you weren't like aware of it, is identified a pattern and kind of applied it to this domain. You're like, well, there's these three different things and the file is called task. And so they're probably about working with tasks. And so what does it mean to add tasks or mark a task as done or to list tasks, right? And you made some kind of like conjectures about why those things might be in place. Is that correct? Is that kind of where your brain was going?
Correct. Okay. I'm only looking at one now, yeah.
Yeah, exactly, right? So you use the information in this one file to make some assumptions about the code base, which is great, because now you're sort of identifying these ways that the words are being used in the code and what they might mean. And that assumption is going to really help us because we probably don't want to have to understand kind of the entire code base, especially if it's gigantic, but want to sort of see where the patterns are and what things are being used. But for the sake of kind of digging into and building comprehension about this particular piece of code, the next thing that I'd like to go into is like, okay, if I were to ask, all right, what happens to the argument I pass into add? What does the add function actually do when I give it an argument? And so for to explain this, we need to go back to our add file and say, okay, now I know that add is exporting this function that takes in, okay, so it's called a task title here. Now I know that the argument I gave it, which in here is being called second argument, in the add function, it treats it as a task title. So now it's actually, I'm giving it a title for a task, which is kind of a further piece of domain knowledge here, right? And this task title, it's now using our data file. So here we'd have to kind of go back and understand what datafile.read does. But it looks like, okay, so it's reading something and returning tasks, which looks like an array because it can call push on it, and adding a new object to this array with the title. Okay, so here's where our task title gets used. We kind of trace this down, you can see that it's now pushing on a new object using our task title as the title value in this object, complete being false. And then finally calling datafile.write, which then takes a callback and logs out this created task, which is what we saw down there. with task.length. Okay, so just using task.length here. All right, so a couple things we found out. One is that add, the argument you pass to add is actually the title of the task. So now I know kind of how I have sort of one command carved out from this whole project, which is that the add command takes in a task title, adds a command, and I could kind of make some similar conjectures about done and list. Well, I would assume that done probably changes the completeness of the task, since add also has this complete false. Maybe done changes it to true. And maybe list just prints out the tasks. And to see how each of these things work, we could kind of take a look at each of the files and see what done takes. So here done takes the task index. So here's another way that the variable second argument here is being used by these different functions as different contexts. So done takes in the index and looks like sets task complete to true. So that kind of validates that one assumption about it switching the completeness from true to false. And list here looks like it logs some headers and then logs the task title along with its index +1. Okay, so we've now kind of constructed a bit of a map, and we're running sort of close to the end of time here. But I'm curious if anybody has like other questions about how this code works, or maybe sort of alternatives or things that are still fuzzy about sort of how this code all fits together.
What happens if one or both arguments are omitted?
Great question. Okay, yeah, what happens if one or both arguments are omitted? So in other words, what if second argument is blank, right? Let's make some, before we test it out, let's make some hypotheses. So Jonathan, do you have a guess? Let's take the add argument, for example. What happens if add doesn't get any argument? Or how would you find this out?
Well, it should, I mean, if it's going to be well behaved, it should take you to invalid argument, and that depends upon an assumption about what happens if argv index 2 and argv index 3 don't have anything to refer to. You want to make sure that that's not going to throw an error that's going to just crash your program.
Gotcha. Okay, so you're making some ideas about sort of how this code should be designed. So if it doesn't receive the proper arguments, it'll throw an appropriate error as opposed to just crashing the program silently or not doing anything useful.
Right.
Okay. So we can test that by saying, well, let's just try calling node task.js. Invalid argument. Okay. So we're getting invalid argument because why invalid argument? Can you all see from the code why that would be printed?
Because second argument is undefined.
Undefined, right? Okay. So when it's undefined, what happens to the code? How does the code respond when this argument is undefined?
It breaks because
yeah. So we'll see when if this is going to be, so if we just say this is undefined as opposed to it being process argv. So now first argument's undefined. So when we switch on the value being undefined, it's going to check to see, does add equal undefined? Well, no. Done doesn't equal undefined? Well, no. List doesn't equal undefined? No. So by default, it's gonna log this invalid argument. So I'd say this is kind of roughly maybe halfway to where you might want it to be, Jonathan, of like, well, it does tell you an error, it doesn't tell you a very helpful error, but at least it doesn't just kind of like crash for a less obvious reason.
Yeah, invalid argument doesn't really say missing arguments.
Yeah, exactly, right? So it might be nicer to have something about like, well, you didn't actually give me a command, you have to tell me one of these 3 commands. Great, so we're kind of going there a bit more into like, discussing the design of this.
Like
yes.
In terms of, would you want to like set these arguments to equal like process argv3 or a default, and then have like an if else, if it is this default, then throw this error?
Yeah, that's a good question. So Debray, what you and Jonathan are both asking are really questions of design, right? These are things where you as coders could spend spend a long time like debating the merits of these different designs, which is kind of gets into the like, can you explain or give rationale for why you would design your code a certain way, or can you see the logic? And what we're actually verging into now, which is nice, we've kind of like done a lot of description and explanation of how this code works. We're now getting to this part of reasoning about it, where you're saying like, well, if we give it something that's incorrect, how should it respond? And thinking about the implications of that result and how we might change the code to make it respond in a way that's more helpful and maybe meets whatever standards of quality that you two seem to be holding. So that's a great kind of like signal that, yeah, we've gotten the basis covered. We sort of know how this code works and what it's supposed to do. And now we can reason about it and think about, is it designed well? And does it respond to unexpected things in a good way? Which I think is a good way for us to wrap up here, just about out of time. So I just wanted to reiterate at the end the kinds of questions that these things that you can be asking. I added some lists of common describe questions and explain questions and what's the last one? Reasoning about questions at the end of this these slides, and I'll share the slides with y'all. Just because I think these are things that you can kind of, at least for myself, I constantly ask myself these questions and I'm trying to understand a piece of code, even if I've written that code myself, sort of check for understanding and to check and see how well my mind is wrapped around this piece of code and what maybe assumptions I might be making and which of those assumptions might be false. Awesome. Thank you all so much for your time, and I hope this has been helpful, useful for some of you.
Thank you, man.
Yeah. And yeah, thank you, Debray. I will see you all later.